Okay, so these are these notes are loaded onto It's Learning. You can print them out or you can just make notes on your paper as we go through this. Um, in your textbook, it is lesson 28-1. Inverse and direct variation. Direct variation, you learned this in Algebra 1. So this right here is really just a repeat of something that you learned in Algebra 1. I will repeat it, though. I will kind of review with you what direct variation is so that you might remember. But direct variation is really just a linear equation. But not just any linear equation. It is a linear equation that passes through the origin. Okay, so it's y equals, instead of mx plus b, well, b is 0 because it has to pass through the origin. And instead of using the letter m to stand for slope, they use the letter k to stand for the constant of variation. Okay, and basically direct variation just means that you've got two variables and they behave the same way. As one increases, the other increases. If one decreases, the other decreases. For inverse variation, which is what we're studying, you have this relationship right here, which you can see is a rational function because why? We have x, which is a variable, in the denominator. So as x gets bigger, y gets smaller, because if x is getting bigger, what happens to the value of a fraction as the denominator gets bigger? It gets smaller. 1/4 is smaller than 1/2. So it is, the variables vary in the opposite way. If one increases, the other one decreases. Okay. So I don't think I can scroll this down. Hold on, I got to get rid of my pen in order to scroll down. So we have, it says, here's some examples. Identify direct or inverse variation or neither. To identify, see if you can put it in one of these two forms. So it's either going to be able to get the y, we have to get the y by itself. And when we get the y by itself, we will either have some number being multiplied by x or some number being divided by x. Okay, so get the y by itself, divide both sides by x, and we have y equals 4/x. This is inverse variation, and we say that 4 is the constant variation. Okay, this one, get the y by itself, you multiply both sides by 2, we get y equals 2x. This is direct variation. And we still identify k equals 2, which is the constant of variation. This has the same name. Okay. This one is neither because of that 3. It would be direct variation, but remember, direct variation is a line that passes through the origin. This one does not pass through the origin. So this one's neither. Okay. So, you guys, this is just a little bit of a review. Direct variation is the graph of it is a line that always passes through the origin. Inverse variation is the graph is a rational function. Inverse variation, the graph never passes through the origin because remember, what does this graph look like? It has an asymptote at the origin, both a vertical and a horizontal asymptote. So that's how we know it doesn't pass through the origin. I'm not going to review this with you because that's just the graph of inverse variation, but we know that that's what a rational graph looks like. So here's some problems that you're going to have to work. And the key to it truly is being able to start with this formula right here. This formula is the key to it, y equals kx. Okay, so let's go back over here. So it says the variables x and y vary inversely. So as soon as you read vary inversely, you run down here and you you write y equals kx, because they say that x and y vary inversely. So you write down y equals kx. Then they're going to give you some information. So you plug that information in. So you plugged in 6 goes in for y. We plug in -3 goes in for x. Now we have an equation that only has one unknown. So we're able to solve for our constant of variation. Multiply both sides by -3, we get k equals -18. So that is the constant of variation. So now when we write the equation for this situation, we know the equation y equals -18 over x is the equation. Now they can give us any other number, and we can solve it since we have our constant of variation. Find the value of y when x equals 4. We have an equation. All we got to do is plug in x, and we get the value of y. We could have done the same thing if they'd given us a y value. We would have plugged in a y value right here. We would have had to solve for x. Okay, so this is really the key. Read it, know what the formula means, or know how to set the formula up. Plug in what you are provided with so that you can find your k. That's really what it always boils down to, finding your k so you can get an equation. Once you have an equation, you can find any kind of missing value that they need. Okay, so most of these are going to be word problems though. So here's an example. It says that the time of day, t, so t is our variables, and it's measured, time in this case is measured in days, that it will take a theater crew to set up a stage for musical varies inversely as W. So you might want to make yourself a note right here and shorten all that and just say, you would just write down T varies inversely as W. T varies inversely as W. What that means is T is equal to K over W. Okay, they did that down here. Now, why did they put an A there instead of K? I don't know. They defined it right here. It says write an equation W and T, find the constant of variation A. Don't let that bother you because they just decided to name the constant of variation, use the variable A to talk about it, not the variable K, but it doesn't matter what you call the variable. So they did the same thing right here that we did. See, as you read varies directly, you write this equation. Okay, then they're going to say if 30 workers can set up a stage in 4 days, how many days would it take only 24 workers? So this is the given information right here. You got to start with this information right here. You want to start here because this is the first piece of given information. This is given. That's how we're gonna use that to find the constant of variation. So 30 workers can set up the stage in 4 days. So you plug in what you know. The T is the number of days. 30 is the number of workers. So you set that up, and now you solve for your constant variation. How do we get the A by itself? Multiply both sides by 30. 4 times 30 comes out to be 120. So now we have an equation for this inverse variation relationship, and we can find out any other missing information. Find the amount of time needed to set up a stage worker for 24 workers. You have the constant of variation. They give you 24 is W, so you plug in 24 and you simply simplify that. 120 divided by 24 is 5. Okay, let's see if we can do this one down here. All right, so probably what you should do at this point is pause the video and see if you can do it, and then turn it back on and then compare your work to my work. Okay. All right, so a theater company plans to hire people to build a stage. The work time T varies inversely with P. So T varies inversely with P. All right, so the first thing that they do is they're going to give us information that will help me find K, my constant of variation. The company estimates that 25 people working for 300 hours. So time is the number of hours. K, I don't know yet, but P is the number of 25 people. Okay, find the work time. Okay, so I got to find my constant of variation. So the first thing I have to do is take 300 and multiply it times 25. So that's 7500. That's what K is. Multiply both sides by 25.